This is Team 10, and we are here to present you our semantic project called AutoGuide. So, to start with, this is our basic ontology of our AutoGuide. So, we basically took the government data sets and taking the data sets from different sources, we created this ontology. So, which have basic features of automobiles, specifications, they being technical in general, dimensions, fuel, performance, ratings, and price. The most important thing, as you can see in this ontology, is these green lines, which basically represent the relationships we have created after gathering these datasets from well-researched and the federal government links, and thereby establishing the authenticity of the data and the vehicle one is looking for. So AutoGuide serves the end user and solves the problem of buying and selling automobiles, be it fair price, proper specifications, or salvage title. So moving on, this is our code over here. As you can see, we have used Flask and we have used Python at the back end and done the front end with the Bootstrap and Ajax. So just to show you a mock query, so this is our Apache Jina Fuzeki server where we uploaded our RDF datasets, and here is where we have the Sparkle endpoints which we are querying. So for example, we have this query where we get the model, exterior, interior, comfort, liability, build, and overall ratings. So if we try to execute them, and the limit is 10. And okay, so before doing that, okay, see, this is our homepage. These are our data sets which we have uploaded. So for example, like we have to query, say, combined data sets. We go over here, and again, like this was the data query we are gonna run. So we run it, and here we get the data. And if you want like more data, we can just increase the limit and see it running. Okay, yeah. So you can see we have manufacturer name, model, exterior, interior, comfort, liability, ratings, build, and overall. So this is how we are querying this server. We're going back to the code. We have, okay, so let's see, for example, we have a feature called performance, which we'll see in the front end. So we have implemented it using the query. We are taking the manufacturer name here and the model name from the front end from the user, passing it in the query, and we are getting the best possible result in this case. We're converting the dataset into JSON format and parsing it using a dictionary. And similarly, one of the important applications of our important features of our application, which is comparing the cars, which helps you in making better decisions and buying the car. We have created 3 queries which run parallelly and fetch the data of the performance measures of the car. So let's jump into the execution of this code. So I'll just run it again just to show you. So yeah, this is up and running, and we copy this URL, and here we go. We have already opened it up, but we'll just open it up again just in case. So yeah, we can see here that the code is running, and for example, okay, let's jump into the performance. And okay, so we have to find the performance of the old car, and say the make is Fiat and the model is, say, Punto, and the year I know this is of 2012 model, and let's submit the query. So here we get the results. It's running. So this data set was the one which we fetched from the federal government. It contained like 3 lakh rows. So here we have the model. Okay, going back to home. So next one is like if you want to know the general specifications of the car. So okay, so say we have a car we have seen on the Craigslist, and so we want to know its general specifications. Say it's a GMC, and the model is, say, Yukon Hybrid, and the build was 2013. So we submit the query. It fetches the general specifications which we have fetched from the different datasets. It queries those all datasets and fetches you the transmission, combined fuel, drive system, highway fuel average, and city fuel average. Similarly, we have technical specifications. As we can see, we have, say, a used car, GMC, and we have, say, sorry, let's take another example. We have got Volvo, and we got V40, and the year was 2011. Submit the query, and here we get the results. We have cylinders, weight, air aspiration, stroke, symboling, compression ratio, and bore, which can help you make very important decisions. So next, one of the most important features of our was the compare cars. And compare car we put in, for example, so we have seen 3 cars come down to it, and we are there to buy it, and we are confused about it. So here we go. We put in like the company, which is like GMC for all of them. And then we put in the model, which is Canyon, Yukon, and Acadia. And the year was 2011, 2010, and 2009 models. So you want to see. So we can see that we get good comfort ratings, liability, exterior, interior, and overall ratings of the three cars, which can help you make a better decisions. So this is how our application is. We also have implemented a price-based search. For example, because like we were asked to in the presentation, and this was an additional feature uh, for our application. So we submit the query and we get all the cars which are there in this price search. So you put in your budget and you can get the cars from there. So see, we have model, cost, and manufacturing, the most important things. So you can go and search for the car and buy it. And we have also scraped the cars over here from Craigslist. You can see the price and the title. You can just go and if you want to buy a car, just go to the website. You have got the dealer information, all the information you can put in our application and run it. So this is how our application works basically. And so to wrap it up, you can contact us over here, and thank you for your feedback is welcome. Thank you. Good one.